Good evening, ladies and gentlemen. It's the evening of the 12th of March 2020. Coronavirus propagates across the world, and I'm doing DCS-BIOS. Let's get a mission up, the A10 takeoff mission, and let's get him spooling and we'll explain what's going on. So any of you who've used DCS-BIOS or tried to will likely have been into the developer guide to try and understand what's going on. So what's going on is explained here. It's as space efficient as possible to enable the export of the complete cockpit state over 115/200 bits per second serial connection. So the challenge for the developer of the protocol was that in order to have gauges work in fast-moving aircraft, altimeters, airspeed indicators, heading indicators, compasses, range, etc., etc., it needs to update very fast, and by very fast, he arrived at 30 times a second, so once every, 333 milliseconds. And he was talking to very low-level, stupid equipment, i.e. these Arduino circuit boards that were going to display the values to the cockpit builder. So that led him, and quite sensibly, to use bit shifting and bit masking. So here's the key bit. So each aeroplane, there are two files that called metadata that deal with things like heading and altitude and speed that apply to all aeroplanes. But inside each, and they have the same construct. So you load those files, but you also have to load the module file. And within each aeroplane, there is a list of controls, which you'll find in your DCS-BIOS scripts or scripts DCS-BIOS JSON directory, which are structured files that tell you about the controls, and they look, if we get the directory, the right directory up, they look, teach grandmother to suck eggs, but you should all be familiar with this directory. So we're in scripts, we're in DCS-BIOS, doc, JSON, and there they all are. So there's a list of all of the aeroplanes. If you take the one that we're going to use first out of the box, and get that file up. Of course it's not coming up, so that's wonderful. So let's do it here. So here's the A10 as the classic example. So now let's search to the ones we're going to use, which is AHCP, or we're going to use in this demo anyway. AHCP, and this, I was trying to be organized and not doing a very good job. So that's a control group. So here we are. There's the AHCP group. So AHCP has relatively large number of controls buried within it. So each control, let's find the one that we're going to use. We're going to use AHCP gun pack, among others. So here's an example. So it's in this group, but the key to notice, or the key things, is each of these controls has an identifier, which is a string in all caps. It takes, you can set it, so it's this one has a max value of 2. but you can also get it. And when you get it, you'll get its return type, which in this case is an integer. So how do you get it? Well, it's got an address, and it's got a mask, and it's got a shift by. And because I'm trying to use C# to build a utility with Stream Deck, I'm not constrained by the same factors that anyone is using a Arduino circuit board or some low-level hardware. I've got a perfectly good PC, the one that's running my DCS on it. So you end up in looking at Wikipedia and trying to understand what all this bit shifting and masking, what it all means and how to use it and how to interpret it. And it's quite hard. And I've highlighted the relevant section on simple low-cost processors. Typically, bitwise operations are substantially faster. So when communicating with these low-level hardware, this makes a huge amount of sense, because what the bit shifting and masking does is allow you to put a quart into a pint pot, as per this advertisement from So Whithead, Big Head, Trophy, Bitter, the pint that thinks it's a quart. So what this does is allow the same number of bits to communicate more information than they otherwise would be able to. The information as opposed to data, the data is obviously constant, but by using shifting and masking, you can put the pint that thinks it's a quart. So you get the idea. So all of this is quite complicated for anyone who doesn't have a degree in computer science, and mine is in modern history, and I don't need I'm not an idiot, or rather I am an idiot, but the guy that's receiving this DCS-BIOS protocol is not an idiot. He's not he's the opposite of a low, whatever we set up here, a low cost processor. He's a high-end Intel i7 or whatever. So the idea was, wouldn't it be wonderful if we could have a library that used these identifiers, once we know what the module is, use these identifiers, could get and set. So that was the goal. So now we can get rid of all of this, and we've got our aeroplane, and he's sitting there, and now we're going to bring the really
This mission starts with the aircraft on the runway, ready for takeoff. You may fly the planned route or just explore the area.
And I've
there are
already
no
made
threats.
it hopeless because I've lost all the buttons. I need to make it a bit bigger. But anyway, in the meantime, let's start the bloody thing. So, what we've done is run a library, and the library will, and you can see already, it's going to read a control and it's going to write a control, and it's going to do that using the path, and the path I just showed you that had all the JSON control files in it for each of the modules. You shove the module name in, or look at the file name and put the equivalent in, and that'll get the library to look at the right file. You've got your IP address here, I'm local, and then you've got your regular UDP ports for receiving the protocol and transmitting the protocol. So here we are in an A10, and we've got TGP is the selected control, so I'll make it as small as I can. But we can see it's this fella here, and he's at 0. So the first thing we're going to do is read him. The library's building a vector, so every time it gets a control, it'll insert it into the vector. A vector's just a list of key value pairs of the identifier and the value. So at the moment he's returning -1 because he hasn't got one. And amazingly, as soon as I go like that, first thing that'll happen is the thing will disappear, and now we're 1, yeah? And if I set it to 0 and we go back and we read it, it'll return 0. And then the other thing we can do is write, and if we go 1 and highlight this thing here and write, and there we are, there's the switch flick, just as you would with your Arduino board when you flick the thing. And if we or rather if I go out and take this away from you and just put a more interesting one in, because that was really simple, it's just a 0 or a 1. So if we put the gun pack in, that goes to 0, 1 or 2. And let's see if we can make this how much smaller we can make it so everybody can see it. We don't need these buttons on the bottom. So there's the gun pack switch. It's 3, 0, 1, 2. So let's read its value. Probably return, oh, it's actually returning the right value. That's because we've left the thing running long enough. DCS-BIOS returns 30 times a second the updates, but every now and again, like every second plus, it'll give you a full cockpit update. So that's returning the right number, because 0 is the bottom value, 1 the middle, and 2 the top. So we could set this to 0 and the switch will go down, and we can also set it to 2 and the switch will go all the way to the top, and then we can read it and it'll return 2, which is what we just set it to. So everything's working wonderfully. So the next thing to do is to prove that because we've used this directory, my directory with all the scripts in it, all we need to do is drop another module in here, the Hornet. We need to do a few other things, excuse me, but we need to stop the server running. We need to come out of here. We need to get into a Hornet. So we go instant action and find a Hornet, and here's a Hornet and ready on the ramp, and we'll play around with the master arm switch because it's bleedingly obvious, and it so we'll control C that in, control V, control V. We'll start this guy again, and he started. Let's fly it. May not work for reasons I won't bore you with, so let's read. We get a -1. Okay, great. So now we don't need the start and stop. We can make this smaller. I can flick that up, go back and read it and stop. Okay, so now we are here back. We're in a Hornet. We've just called the master arm switch. It's returning -1, which means it's not returning anything at all. The underlying language has a concept of none, which obviously isn't a number, so we just set that at -1. Now, quite likely, if I press it'll have changed. It has changed. That's because while I was wittering on, DCS-BIOS gave a full refresh. So now we're getting the right answer, and now just as with the A10 we can write that. So watch the little fella down here, and there he is. He's gone to 0, and we read him, he's 0. We write him to 1, and up he goes to 1. So that's the library. We now need to explain how that works. So we'll ask Mr. DCS, who dominates your screen and messes everything up, to piss off, and we'll start at the front, i.e. the closest to DCS. So we'll go here. So here's C#. So when we're reading a control, what are we doing? We're reading the text inside that text box, and we're also trimming it. The server handle is the reference to the Rust library UDP connection. So if it doesn't exist, we're gonna, if it does exist, we're gonna do this, otherwise we're gonna tell you to go away. So what are we doing? We're just saying we want to return value, and it comes from here. And I think you've probably got the idea that this is a call to a function from the library using the WinAPI DLL import. So it's talking to this DLL, which happens to be in this directory. Could be right next to DCS or right next to DCS-BIOS, doesn't really matter. Need some way to make sure that reference is set. So what we were using was this file here on line 21. We were getting the value of a control which was returning an integer. So that's why it's static, because it's going to give us a return value. It's extern, because it's external. It's going to return an int32. It's called server get, and it needs a reference to the library server, and it takes a string, which is the identifier, which is the HCP-TGP that I was typing. But because it's going out to a C function, it's unmanaged code, so we have to do that flipping to make sure that on the other end the library isn't seeing that as a C string. And server set does nothing different other than this. It needs a value, which were those zeros and ones I were typing, which are U short and the value. And so amazingly enough, the set control, write control, will send the text box of the what I want to write, and it'll convert the value, the 0, the 1, into a U16 so it can get sent across the transom. And what's all this done? This is done with this wonderful language that I was introduced to inside of DCS with that datis application we did for one of the servers that used Rust, and introduced me to Rust, and now used it in work. So what we're seeing here is that Rust is a language on its own. It's not C, but it can pretend to be C. It's just like C in that it's got no garbage collector. It's zero cost abstraction. It combines to a binary file. The major difference is the way it handles memory, because it doesn't handle it itself, but the compiler forces you to handle it in your own code, so you can run multi-threading. And we thought we were going to have to do multi-threading to keep this vector. But nonetheless, the function we were running is server get, and it takes a handle, which is that connection to the server. It takes the identifier, which is a string, and it's going to return an I32. And is there a handle? Is there a value? And if there is a value, through lots of complicated hash maps, if that value, if that control, which they all were amazingly, is of the integer type, it returns the value. So there you are. That's the current status of development. So the idea is that you get and you set. So in your C# or your Java or your JavaScript or whatever high level language you are using in order to control, as long as you're wanting the controller to be a clever PC instead of a poor little Arduino board, then you can just say, you know, here's the range of controls, get me the values, when you've got them, return them, and then you do whatever you like. And the guy just pressed a button on the Stream Deck or some other button box, and I'd like you to send that, so it'll just be the set which we've got here, which takes the handle, which is a reference to the UDP connection, which is building that, if you like, that database key value. It's basically a list of key value pairs. It'll take that, look it up, refresh it, bang it through to the UDP, and the knob will turn in the right way. So that's where we've got. I hope that's useful. Some people might say that, why the bloody hell did you do that? Because there's a perfectly good protocol, C protocol, but it was a little bit difficult. And what this does is eliminate a high-level language user from ever having to look at this ever again and figure out how to get the data from the bit stream that gets passed over, and you know, have to read this kind of crap on Wikipedia, which can get very old very quickly, because we're trying to move along. So the next job for me is to prove this with a Stream Deck duplex implementation, so I can press a button, and I can press a button either on the Stream Deck, which will reflect in the cockpit, or reflect in the cockpit and change the state of the button on the Stream Deck, and so on. And if anyone would like to suggest which module and which control set you'd like to see that in, whether it's in the Hornet UFC or the KA50 data link panel, or the KA50 autopilot panel, or some other control set where you think the idea of having an external and internal, and the two talking to each other, and the lights coming on when it's on, and keeping that in sync. If anyone can think of an idea where that would be interesting and indeed useful, then please let me know, and I'll put the time into developing a sample application there. So now we can sign off with I think we should sign off with this, that the whole idea of this library is that nobody ever has to look at this page ever again, because it's really simple. You get ahcp_tgp and it returns 0 or 1, and you set ahcp tgp equals 0 and it becomes 0. Thank you very much. Good night.